Hello, everyone. In this video, we will introduce linked lists. Array lists is implemented using an array. It is not efficient if you want to insert at the very beginning of the list and you have to shift everything to the right. If you delete the first element from the array list, you have to shift all the elements to the left one position. So the time complexity for deleting, insertion of the element at the beginning, it's order of n. Using linked list, we can implement it in a way it's going to be order of one time for insertion and deletion at the beginning of the list. So let's look at the linked list. This is the animation for the linked list. It's now empty. So we maintain this two pointer, head and tail point to the first node in the linked list and the last node in the linked list. So let's add some values here. Insert. So now this is a node contains the element. Another element, 5. Now we have this two nodes. Each node contains the element and the nodes are linked together. So this is why it's called linked list. 25 is here. And now you can insert an element at the beginning is 11. So this is 11 right here. So here's the head and tail, and the size is 4. And you can add more elements and remove elements. So this is the big picture of a linked list. Let's look at a little bit more in detail now. So this is the diagram. You can see a linked list, a head and tail. So these are the nodes linked together. And nodes are objects, and objects are defined using a class. So here, this is the class. Node contains the element, and it contains a link to the next element. This is the constructor to construct a node, the class node. Let's add a couple of elements into this linked list. So let's have first, we have an empty linked list. Then head and tail are all null. So we're going to add the string elements into the linked list. We're going to add now, this is Chicago. So we create a node Chicago, and it's now the head, and now assign head to tail. So this is one node linked list. And add a node Denver. Right here is a Denver. And we're going to have this is linked to tails next. So here's the Denver linked to the tails next. And we're going to have this tail is now changed to point to Denver. This is tails.next is assigned to tail. Add one more element, dollars is here. So the dollars is tails next is pointed dollars. And then we're going to move tail to tails next. You can traverse all the elements in the list writing a loop like this. And here's the current starting from the head. Current is not null. We're going to print the element is current.element, and then move the current to the next one is current.next. All right, so this is the class for MyLinkedList, it's going to implement the MyList interface. The data fields head and tail, the size, and the constructors, and the methods add first, add last, get first, get last, remove first, remove last. The linked list consists of the nodes. So this is the node here. The node, the data field is element and next. Let's see how we're going to implement add first. Add first. We're going to add one element right here. It becomes this. So let's look at the animation for add first. This is the add first.
The add first element method is invoked to insert element at the beginning of the list. Empty or non-empty list. Enter 0 or 1. Note that you can use mouse or finger to move this dialog box freely. This animation shows how to insert a new element to the front of an empty list or a non-empty list. Enter 0 for an empty list and 1 for a non-empty list.
So let's enter 1 for inserting element to a non-empty list. You can play it with a different scenario. So let's have 1 now.
The list is initially non-empty.
Remove first is to remove this one out.
The statement creates a new node for the element and the address of the new node is assigned to new node. Check your understanding after this method is finished. What will be head and head.next.element? Enter your answer separated by a space.
After this method add first is finished, what will be head and head.next.element? What will be the head? Head will be you add first. So you're going to add to this new element. So head is going to point to the node for the new element. And this is going to be, look here, this head will be the new node. So this is the one. So what would be the head.next element? That's going to be E0. So head.next and this next one. So after you put the head right here, so this is going to be E0. Enter your answer separated by a space. So look at the code here. So this is the new node. You create a new node. So this, after this finished, this head will be this new node. And the head.next.element and will be E0. Let's give it a try, see what happens.
You are correct.
So this line creates a new node containing element E.
The statement assigns head to new node.next.
Link them together. And now head
The statement assigns
points
new
to
node
this.
to head. Now head points to the new node.
Increase the
The
size.
statement increases size by 1. We assume that the list is not empty in this case. Tail is equal to null is false.
We have the implementation for add first, add last, and also the animation. Add into a specific location, remove first, remove last, and remove from a specific location. All the detailed implementation along with the animation to help you to learn all the detailed implementation. So please study it after the video. Let's go back to this UML diagram. You click this My Linked List, you're going to see the source code. So this is the detailed source code. My linked list implements my list and with all this implementation. Please study the source code. Thank you for watching this video. See you on the next video.